Do you ever feel like your data is a set of puzzle pieces waiting to be put back together? In this video, we're going to do just that. We're going to look at techniques like merge, join, and concatenate to bring together our various data tables and take advantage of each of these techniques for helping us to tell the complete story. Let's get started. To begin, we're going to import Pandas and get our environment ready. And as you can see here, we're going to go over merge, join, and concatenate, as well as some general watchouts and some advanced use cases at the end. To begin with merge, I'm going to create two simple data frames, and I have a view here, so if you want to recreate this, you can. I'm just showing that we can import Pandas here. And we have our data frame generated from these two dictionaries where we have a sample data, so this is sample information, and then a concentration and mix per mil, as well as measurements. So we have, again, that sample ID and some absorbance values at 280 nanometers and 320 nanometers. So you can see we have a metadata table here and our actual analytical data or measurement data on the other table. And we can visualize what these two look like by running the display, and you can see we have our two tables. Importantly, they share a column where we have the same ID, so this index value here. And this is where merge is a great technique because we can use the pandas.merge method and then merge on the left side our sample data. So this is that metadata. And on the right side, we can merge the df.measurements or the measurement data, and we can set on to sample ID. However, if they had two different names, we would just use the left on and right on to specify the right column name or even index in this case. Next, we're going to set how to enter, and these are going to find the values that are present in both data tables. So when we run this, you see we have our merged data where we have sample ID 1, 2, and 3, which would be the inner merge of sample 1, 2, and 3 here, as well as 1, 2, and 3 in this table. Note that 4 and 5 are excluded. If we want everything, we can set how equal to outer, and this will provide all of the sample IDs, and then use the fill with missing value indicators as in again, where those samples are missing. If we really want to focus on one data frame or the other, we can just set how as left or right. And this will preferentially set the ID based on whichever data frame we are assigning. So in the left, we'll see we have S1 through S4 with missing values for those respective values. And if we set to right, you see we have S1, 2, and 3, and then S5 with those missing values. So this is a very powerful technique. Here are some of the takeaways. This is good for combining your sample metadata with experimental results, as well as merging data sets where we have a common identifier or index column of some sort. Some of the watchouts are where we have some mismatches or IDs that are not present in both. And as I showed you, we can address this with using inner versus outer, left or right, and just really find the right conditions that meet our needs. And then if we have duplicate keys, we're going to actually address that later on in the video. So let's keep going. Another technique we can use to join our data tables is the join method. So let's look at the results table and a properties table. So I've got two data tables where I have my sample ID as an index and the sample ID here as an index. So that was generated from this here, where this looks very similar to what we did in our merge, but now the IDs are in the index position. So this is sort of a sub condition for the pandas.merge, but specifically for where we're joining on both indices. And so we're going to join in a similar fashion where we can just take one of our tables, so the df.properties, and we're going to use the .join method and join the results table. I'm showing that we're going to begin with an outer join, and we're also going to use the left suffix argument. With this data table, you see we have all of our sample IDs because we're using the outer. So this is the same as what we saw in the merge. And we have compounds A, B, C, D, and a missing compound. And you see because of this, we also have missing data from the other side of our table. And this looks very similar to the output that we would get with pandas.merge. But again, this is sort of a sub case for where we're merging on just the index values. So this is not quite as flexible as the .merge method. Accordingly, we have the same options for how, where we can just do an enter. And what I'm showing here is that we can actually use this suffix here in the event where we have multiple data tables that have the same column name. Let me reset the index. in both of these. And that way, we're actually still going to merge on the index, but we're going to have a case where we have sample ID in both of our data tables. And when I do that, you see we have sample ID left. So these are these sample IDs that are coming from the left side, indicated here. And then we have another sample ID here that's unlabeled. And so we can use the R suffix, and let's just set this equal to underscore right. When we do this, you see that we now have sample ID right. So this is good if we have data table where we have some of these same columns. This gives us some flexibility. This could be really good when you're using SQL and maybe you have multiple data tables with overlapping information. Okay, so some of the takeaways. This is good when your data is indexed by a common key. So again, I want to focus on the fact that our sample ID initially was in the index, and this is particularly where join is best. And especially when you want to join multiple large tables. So you'll see this a lot when you're actually going at a database using like a SQL database, and you'll oftentimes use join rather than merge. Some of the watchouts are cases where you have some index misalignment or missing indices, and how the outer, when we set this here, can impact your data table. So just keep an eye on that. Make sure you know what the data should look like based on the conditions you're using. Next, let's look at concatenate. So we're going to modify our data tables just a little bit. In this case, we have, let's say, experiments from day 1 or some experiments at 1 and another experiments at 2. And so you can see we have different IDs, S1, S2, with an associated measurement. And in our other experiment, we have different samples, S3 and S4, with more measurements. So these could be pH measurements for all the samples, but maybe collected at different times, stored in different Excel tables, you name it. So let's get those variables established. And let's focus on a vertical concatenation. And so let me just show you what this looks like first, so you have a better idea of what I mean by vertical versus horizontal. So here you can see we're stacking vertically. So our initial experiment 1's at the top, our experiment 2 is at the bottom, and I have the ignore index commented out. So you see that we're taking the index values from those original data tables. Commonly, you just want to set ignore index equal true. So the new combined data table, the new concatenated table, is now re-indexed. And notably, with this method, you're passing in all of your data as a list. So you can see we can pass in any number of items into this list as long as we have the same columns. And so this is a really flexible way to combine lots of data tables together. And so this is really good for when combining data sets, particularly from repeated experiments. Say you're running a multi-day study and you know you're going to be collecting the same measurements on different samples, and you can just combine those tables together. Some of the watchouts can be duplicate entries. As I've just shown you, I can easily just add another data table to this. Now, there are ways to address duplicates pretty easily with Pandas, but this is a major watchout. Another watchout is ensuring that your columns are consistent. None of those small tweaks. Again, a column with white space is different than one of these columns without that white space. So we do want to make sure that we're cleaning up the data tables before we do this concatenate, in case there's different experimenters, different scientists with maybe slightly different naming conventions. So next, let's look at horizontal concatenation. And this is a case for where you have maybe all the same samples, but you're now running a different experiment altogether. So let's say in the first experiment, we were looking at pH on 4 samples, and now we're going to look at a density measurement or some other measurement altogether. And so we're going to take those samples, take some density measurements, and store this as df.additional. And now let's concatenate that original information with this additional information. We're also going to set axis equal to 1, and you see we're still passing in a list. So with df horizontal, we have our original 4 samples as 1, 2, 3, 4. We have our concentration that we may say measured earlier, and now we have a density measurement as well. So now we're able to add more data to this experiment. Of course, we would need to now clean our data table up again or add a suffix so we can know where these sample IDs are coming from. And since they're duplicated, we also can just remove one of those columns altogether. So this is really good for when you're combining different measurements for the same samples and adding more information to your data set. So again, it is about putting more of the pieces together. One of the major watchouts with this approach is aligning your index values, as you could get a lot of missing values. So let me show you. if I set the index on df additional to sample ID, so let's just really sort of skew this data set really quickly. If we rerun this, now because the index values aren't the same, we are getting a lot of missing values because we are no longer aligned. And so this is one of the major watchouts with this technique. Obviously, we visually can see the way we want the data to come together, but that did not happen because of this small error here. And this is quite common depending on how you've assembled your data tables or the source information. So here are some general watchouts where mismatched columns or index values can really plague these sorts of studies. So you definitely want to check the data flows, do some data cleaning, check for duplicate keys, particularly during your merge, as this could really skew the type of data that you get. Sometimes you need to aggregate those keys. For instance, if you have multiple sample ones because you've measured your samples in triplicate, that's a major watch out. As well as missing data after your merge. Another watch out is missing data after your merge or join. And this could be the case because we've set our data to outer or left or right. And so there might be values that are present in one table and not in the other. And now we're going to have some missing values. Lastly, column name conflicts can also become a major issue, particularly if you're tracking your data in Excel and you're maybe combining Excel tables, and simple things like added white space or differences in your cases, such as experiment with a capital E versus experiment with all lowercase letters, will be seen as different with Python. So you really want to make sure you have a way to clean up your columns, clean up your index values, clean up your data tables before you perform merge, join, or concatenate to ensure that you have the best and expected output. So here's an advanced case where we're going to actually merge data frames using multiple keys. So as I mentioned earlier, sometimes you do have duplicates or triplicates, and this could be because of maybe replicate measures on the same sample. So maybe your sample ID is the same, S1, but perhaps you have multiple batches or multiple replicates. That's also an important key. So in this case, we have sample ID 1, 2, and 3. We have batch 1, 1, and 2 here, and 1, 2, and 2 there. And so when we use our pd.merge method, we're still going to set the left data frame as the left sample, and the right would be the right measurements. However, for on, we're going to pass in a list of columns. So we're going to pass in sample ID and batch. And so we're going to look for unique combinations of the sample ID and batch ID values, and those will become the keys from which Pandas would then look to merge our data. When we do this and we set how to enter, there are only two combinations of sample IDs and batches that are matched between these two data, S1 batch 1 and S3 batch 2. Again, if we set the how to outer, we will have more combinations with missing values. And if we set how to left, you will see how we can change the results of this data table. And this is why it's really important to understand the relationship between these keys, the shapes of the data, the various columns, and how they will be impacted with merge, join, or concatenate. So with this, we're able to now bring those pieces together to build the right data table to help us drive insight for the business. If you want to see more about these types of methods, like, comment, subscribe. If you find out that you do have missing values, check this video out here. If your data table is completely empty, check this video out over here, and I'll see you in the next one. Peace.